Hello fellow YouTubers, this is N0AGI. I thought I'd do a quick short video about my STPO tool. This is an updated version of the tool, and as you saw in my previous videos, this tool allows you to track satellite pass-throughs. It also tells you when the pass-through will occur, what time it will occur, what the duration would be for that pass-through, and what the elevation is for that pass-through. And then it can also send you an email notification when the pass-through occurs and after the pass-through occurs. It can also kick off an external batch file when the pass-through occurs, the on.bat file, and then the off.bat file when the pass-through completes. What I'm going to cover today is the circuitry that I'm going to enable in this application. As in, when the pass-through occurs, the application will automatically turn on a relay switch, and then the relay switch is hooked up to your radio, and the radio will be powered on when the pass-through occurs, and when the pass-through completes, the circuit will be switched off programmatically. That way your radio is not up and running all day long, but only when the pass-through occurs. So this video is about that circuitry, and give me a quick second, I'll be right back. Alright, so here is a very simple, very easy to put together circuit to make this work. So basically what you're seeing here, this is a USB to DB9 or USB to serial adapter cable. It is currently connected to my laptop, this laptop here, through that USB hub. So the other end of the USB to DB9 or USB to serial cable is hooked up to my relay switch here. I got this from eBay. I think I paid about $3 or whatever. This one is rated for 30 amps, and which is probably a pretty good deal for the price. I think this will do really well for controlling your ham radios. So really, what this does is we only will need two wires from the USB to serial adapter. One is a grounding wire, and the other is a request to send wire. So we only will need two wires. The switch has a DC in positive and negative because the switch itself needs a power supply. So this is a typical 9-volt battery pack. The other end of the switch has normally open, normally closed, and a common port. So basically, I'll explain that in a few seconds here. But basically, what that does is when the relay switch engages itself, we want this end of the wires to be connected mechanically, so to speak. So when they are connected, the circuit is closed. When the circuit is closed, the radio is powered up, and when the circuit is open, the radio is switched off, obviously. For now, just for our testing purposes, what I've done is I've hooked up these two to my digital multimeter, and I hooked it up to the continuity option here, so that when the circuit is on, this guy makes a quick beep so that we know that the circuit is working. So before I demonstrate how this works, let me do a quick summary of how this is connected. So basically the way it's hooked up right now is that's a relay switch rated for 30 amps. There are 3 ports on this side and 3 ports on this side. This is where you hook up your 9-volt battery, the positive and the negative. And then the third port is what's called the signal in. That will be hooked up to your USB to serial DB9 port, the two wires we talked about. The only thing that you should keep in mind is the grounding wire and the signal or the request to send wire has to be flipped so that the request to send wire is hooked up to the DC negative, and the grounding wire is hooked up to the signal in. There is a normal jumper header on the relay board that has normal low, normal high. This one has a default normal low, so hence the reason why I've switched them or flipped them over, so the request to send goes to DC negative and the ground wire goes to signal N. And the other side of the USB is hooked up to your laptop. On the far right here of the relay board, we have normal open, normal close, and there's a common. So the way this is hooked up is basically you would connect your radio. It doesn't matter which one that is. It could be positive or negative. In this example, I'm connecting my radio's negative wire to my power supply, and the power supply's positive goes to normal open, or you can even go to common. It doesn't really matter again. So it's connected to normal open, and the other positive side of the radio is hooked up to the common, so that when the relay engages, these two wires are shorted or connected so that this circuit completes and the radio is powered up. When the relay disengages, the circuit is open so that the radio switches itself off. And this happens automatically every time the pass-through occurs in the STPO tool we just talked about. So let's go to a quick short demo and I'll be right back. Alright guys, so here's a quick, very simple application I wrote in C#. Nothing more than opening the COM port and closing the COM port. Opening engages the relay, closing disengages the relay. Over here, the relay board is powered up, and you can see the LED indicator shows that it is powered up by this battery. And there's another LED here that lights up when the circuit is closed. In this example, however, since I've hooked up the normally open and common ports to my digital meter for the continuity option, it should sound a beep. I'm going to click the open button right now. It says it's closed up on the top there. I'm going to click on this open button, and then that should open up the port. So let's do a quick click here. 1 second. I want to quickly open rather. So let's go to a relay. As you can tell, this LED is now lit up, and the multimeter is working because these two are now connected with each other. Now I'm gonna go close, or click on the close button, and it closes or opens up the relay. Now let's do it again. Open the COM port, close the COM port. So when I open the COM port, the relay is engaged. When I close the COM port, the relay is disengaged. So that's a quick short video, guys. So let me also show you the sample code, or the quick and dirty example that I've used to build out this app. The logic for this open close will be embedded in my STPO tool. So this is nothing fancy really. As you can tell, when the button is clicked, if the serial port is open, say, hey, we're going to close the serial port now. So it basically sends off an off byte, disables the DTR enable option for the serial port, closes the serial port, and we're done. When I click on the open button, it checks that, hey, the port is not open, so it's going to go ahead and open it, enables the DTR to true, and then writes a 255 byte to the port. So that's it really, nothing fancy, and this can be implemented in whatever language that you're comfortable with. I just chose C#. So right now I'm gonna go and hook this up to my radio and see how that works. That'll be a part 2 of this video. I hope this was useful to you guys, and thank you so much for watching. We'll talk soon. Bye.